The future is watching. Welcome to Opcode Virtual Summit.
Hi, I'm Yarden. I work at engineer doing research and dev. I previously worked at Centennial One, did a few roles there. And I'm a circus artist about half the time. And now we're going to talk about WinDbg, 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 however you like pronouncing it. It's a very strong tool for debugging Windows, but until a few years ago, it was also a real pain to use. But a few years ago, why can't I hold that? Up to a few years ago, Microsoft added the new debugger data model that you can access through the dx command. This data model gives us support of native objects through NatVis. These objects are defined in XML files. There's plenty of objects that are defined by default, and also you can go and define your own objects to use them. You can also interact with all these objects through LINQ, which is an SQL-like language. You can query them with select, where, you can order them, and do lots of other stuff. The main thing we get from this DX is that we don't need to use MASM anymore. At the bottom of the slides, you can see a MASM command that lets us see the name for an object. The whole 2 lines is one command. It's horrible, and if anyone can read that or write that, then you get points from me, and I apologize that you ever had to learn that. So what we can do with this DX is first we get some new registers. We can define our own registers. For example, I define a register that I call my string. We can pick whatever name we want. That is the string. It can also be a number. It can also be of any type that it knows about, any type that's defined in the XML, or as we'll see later, it can also be some dynamic types. But other than that, we also get some built-in registers that are very useful, like cur thread that shows us information about the current thread. So this is not directly the kernel thread. This is a container that contains some information that we thought might be useful for us. For example, the stack, the register state for this thread, and the kernel object that is actually the thread. We similarly have cur process, also has a fake name. Under IO, we have the handles, all the handles that this process has. Now you can see that this array is not indexed by 0, 1, 2, 3, whatever. It's indexed by the number of the handle itself, which will be useful. We'll see that later. We also have cur session. That the name might be confusing. This is not a kernel session. This is the debugger session. We have the debugger session here. That's the IP of the machine that I'm debugging. That's my key. Now you all know, and the port I use. And in this cur session, we have the array of all the processes in the system. And like with handles, this array is not indexed by 1, 2, 3, 4, by 0, 1, 2, 3, 4. It's indexed by the process ID. And for those of us who, which is probably all of us, we're used to seeing process IDs in decimal, we can do dx cur session dot processes, comma, d. This shows us all the numbers in decimal. Now let's say we have a case where we want to find some information in the Process Explorer exe. In the old way, we had to run bank process 00 explorer.exe copy that address, which is the address for the eProcess, and do dt nt eProcess address. Now look at the eProcess. We can also search for something like image file name, and we see the file name for the process. That's a long and kind of annoying thing to do. With dx, we can do all of that in a very simple command, dx per session. We have processes. Now, I said we can use link. Link lets us do where to filter out only the processes that match our requirements. So where gets a process, we'll call it P. An arrow, and we only want processes where p.name, because this is a container that gives us, among other things, the parsed name of the process, equals explorer.exe. This is going to return an array of all the processes that match that. In this case, we only have one, so we can do dot first and get the process itself. Now, what can we want to see in Explorer.exe? Example, it's signature level. That tells us how it's signed. It doesn't tell us who signed it, but it tells us which level it's in. If it's unsigned or signed by Microsoft or Windows signed or whatever. Now we take our process and we go to its kernel object, which is the eProcess. And inside it, we find signature level. By the way, all dx commands are tab completed, which is awesome. So we printed our signature level, which in this case is 0. Now 0 doesn't mean I have some weird unsigned Explorer.exe around the machine. 0 means unchecked, because signature level is only provided when needed. Not every new process is going to have a signature level automatically. 1 means unsigned, but 0 means unchecked. So now let's take a look at the signature level for all the processes in the system, which is a thing that would be really annoying to do. Without dx, you'd need to use for each, which I never personally liked. So again, we iterate over all the processes on the system, but now not with where, because we don't want to filter. We do select to only see the attributes that we want to see. So again, for each process, we want to see p.kernelObject.signature level. We see here like stuff like 3E, 3C, 1E, but we only actually care about the bottom nibble. The top nibble tells us stuff like where this is a PPL or a protected process or stuff that we don't really care about right now. So we take our command and we zero out the top nibble to an end with 0xf. Now we have nicer stuff. But let's see that as decimal because it's easier to look at in decimal. And now we can see slightly more familiar numbers like 12, which means it's Windows signed, 14, it's TCB, a few more. We can order them too with order by if we want to. Now we see that process with ID 4852 is Windows signed, but we don't know very much about this process other than that. And yeah, we can go back to the process array and get this process and look it up, but we can also do something easier. We iterate over all the processes, but we only chose to get signature level for each. Instead, we can choose to get a few attributes. To do that, we need a new type that contains, for example, a name, a process ID, and a signature level. So we can go to the XML and define our new type, or we can use a dynamic type that is called an anonymous type that will only be used in the command where we define it. So the way to define an anonymous type is with new, curly brace, name of field equals value. We have a field called A that contains the letter A, and a field called B containing the number 4. So now we have our new type that we defined in this command. So we can do something similar. We go back to our command where we iterated over all the processes, and instead of just getting the signature level, we define a new type with name equals p dot name, id equals p dot id, which is another attribute, and signature level is our signature level. Right now, we only see an array of processes. If we click on one of them, we do see our structure, our type. But if we want to see all of them at once, we need to add -r2. The -r tells us the level of recursion it's going to show us. The default is R1, which is only going to show the first level. So we're adding another level. And I can see all the processes and their signature level. And a wonderful thing that was added is grid view. We run with -g, and we get this beautiful table with process name, ID, and signature level. And these headings marked in blue are clickable, and they sort the table. Yeah, we click on names, and now we have names sorted alphabetically. The annoying part about sorting with the headings is that they remove the formatting, and now everything is back in hex. We can do order by manually, so we do get form. So this way we can see an attribute, a specific attribute for all the processes on the system. We can also do that for any iterable thing, all the threads, all the APCs, all the whatever it is that we want to look at. So this is one thing we can do with DX using the built-in registers. Another pretty useful change that this added was a change in breakpoints. There's a few things that were added for breakpoints. For example, a function to easily define a breakpoint over access to a variable, reading or writing from it. Basically, a slightly easier way to do BA. If anyone knows the command, and also a way to put a breakpoint over a source file. Now, if you have your C file and you want to put a breakpoint over that, there's a function to do that now. Again, it was possible before, but slightly obscure and not very well known. But the thing I found myself using the most is a change to conditional breakpoints. Now, again, conditional breakpoints were available before too, but they weren't very comfortable, very convenient to use. But now we can do BP/W and run dx command. No need for dx here, but that command here will be our conditions. And then we can place our address. So let's say we have an issue with threads writing into files while the thread is impersonating a different process. So the way we'll write a conditional breakpoint for that is BP/W, and our dx command will be tab completion is annoying here, so we'll do it here first. We can see if a thread is impersonating by running cur_thread.kernel object to get to the e-thread. Search here for client security. And in client security, we have impersonation data, which tells us whether or not it's impersonating or not. Now, in this case, impersonation data is 0, which means the thread we're running in right now is not impersonating. If this is anything but 0, this is an impersonating thread. So we'll take this command and do BP/W. Current thread impersonation data is not 0, and we'll place our breakpoint on empty write file, because in our hypothetical scenario, that's where the problem is. So place our breakpoints, keep running, and we hit our breakpoint. Let's look at the thread's impersonation data. And it's a pointer. It's not 0, which means we are running an impersonating thread. But Let's say we don't want to break in every case. We want to just print out some information and keep running. So there is a way to do that with, after the address, we add another set of quotes with whatever command we want to run, and G to keep running. Now, this command now can be a DX command. So let's print for each thread its client security. So cur thread dot kernel object dot client security. And it is printing the client security for every case where the breakpoint is hit, which is awesome, but still doesn't give us all the information we might want on the thread. For example, we might want to get the thread ID or the process name. And we can't do that with the anonymous types that we just saw. So instead of printing client security, we'll declare a new anonymous type with thread ID being per thread.id and process name being current process.name. Yeah, we get a thread ID. We can also run this with formatting to get the thread ID in decimal. Seems like TI worker is, some threading TI worker is writing into a lot of files. Does make sense. We want a bit more information here. And we do want this information, the thread ID and the process name, but we also want some information from the impersonating thread. Specifically, which account it's impersonating to. Is it impersonating local service or network service or system? We get that by looking at the authentication ID inside a token. Let's just break. Okay. A second, let's just break here. So we have our current thread, client security. Inside client security, we have an impersonation token, which is actually the token of the thread, of the process it's impersonating. Now, it's not aligned. The token has to be aligned, which means we just need to zero out this bottom nibble. Like client security impersonation token. And we do and not 0xf, which is my lazy way of zeroing out the bottom nibble. And this is a pointer to a token. Now I can actually see this as a token, not as a pointer. But right now, this is just a void pointer. Yeah, that's the official Microsoft type. This is a void pointer. So WinDbg doesn't know how to parse that. But to know how to parse this token, we need to cast it. And casting with DX is very similar to ccasts. We open braces, empty token. This is a pointer to a token. We need to wrap these two for precedence. And now this is actually parsed as a token. And see that this is very similar to ccasts. And like in a language, we have operation precedence, so we need to wrap all of this in braces. So we do the end before we do the cast. So inside that token, we have authentication ID. Now this is a pointer, so like you see, we need to do an arrow. Sometimes the tab completion breaks. And inside that, we actually only want to see the low part. So we've got that. Now we can take this and add it to the structure that we're printing every time the breakpoint is hit. So we're adding to our type authentication ID is the structure, right? We added back. Oh, we need to add back the part because we want to keep running. So we'll see we see a few more processes running into files here. We can see who they're impersonating. This is actually a hard-coded list, so you can go and look up which user account means which number. And the last part we might want to see here is it could be interesting to know what file the thread tried to write into. How can we know that? We are setting a breakpoint on empty write file. So empty write file is receiving as its first parameter a handle to the file it's about to write into. First parameter is saved in RCX in the register. And when we have a handle, we can actually use the handle array that we saw earlier that each process has to find the file that this handle is for and get its name. So again, we'll break once instead of running. Now we see RCX looks like a handle. Let's do. That's the handle array. And in that, we want to find RCX as the index. Yep, that's a file. And to find its file name, we need to go to object, that's the object header, and underline object, which points us to the object itself, which in our case is a file object. Now, file, because this is a file object, it has a file name. Well, someone is writing into Windows Defender, into the Windows Defender database. I'm going to guess that the Windows Defender on my VM started running again and is doing scan. So I can take this and add another thing to our type. So we add our last member of the type, file name, which is the current process, which we search the handle array to get the file name. And now we can keep running. And my debugger session died. I wonder why it does that. But it died just in time because this is the last command for this talk. And we can actually see for each case, thread ID, you see the name of the process, the authentication ID telling us which user it's impersonating and which file it's writing into. Now, some of these don't look exactly like files, look like, sometimes we see pipes here, lots of stuff. And yeah, that is the Windows Defender process writing to the Windows Defender database. Now, this is just my example. You can use any kind of fields you want. And with DX, you can even write all of this output into a file on your host machine, which we don't really have time to show, but it's a really awesome capability. And this is just the tip of the things that you can do with this debugger data model. There's a million very useful things you can do. I recently published two blog posts about it. Other people published blog posts too. You can also use JavaScript to script things here and do even more useful things. And actually, this is pretty well documented. There's MSDN documentation, and every command is documented. If you run a command with -v, it will show you the inline documentation for it. And as I said, it's tab completed. And if you run, let's see if I can show it. Okay, we got debugger back. We do dx cur process dot nothing, and I just click tab, it will show me all the different options here, all the different attributes that this has. And if I do debugger dot something, it will show me all the different options. This actually hosts all the capabilities. There's, we have settings, we have utility. Yeah, under debug utility control, we can see execute command that lets us run a legacy command, like a legacy extension. We can see the different breakpoint options with the documentation, what they receive, what they do. So go investigate that for yourself, find the scripts that are useful for you. I have a GitHub with some useful scripts. I'm also gonna upload everything we did here over there. So yeah, take a look, do stuff your own, and stop using MASM, please.
Yeah. Can you still hear me?
Yep.
Oh, cool. Yeah, because you turn off your webcam. You can keep it on actually if you want for the Q&A.
Oh yeah, sorry, I didn't know we had Q&A. Yeah, if there's any questions.
Oh yeah, that's the best part actually, because we get some questions in the chat and stuff.
Awesome. Yeah, I had no idea how this worked. So yep. Any questions? I'm here.
Yeah, so regarding the question, so there's one question in the chat, and while we are at it, if you guys have any more questions, don't hesitate to ask your questions. So the first question we have is from Maxim, is asking how to display all the lines without putting the dx-c100 argument in WinDbg, for example, to display modules. What's the -c argument, by the way? Is it count or?
Yeah, -c is count. For example, if we do first session dot processes, it doesn't show us everything. There's dots here, and yeah, we can do -c100 to see the rest basically.
Otherwise, was the default limitation?
The default limitation is, I think, 64. I can't remember exactly.
Oh, I see what you mean. So it's easy to think that's
hex, I think. Yeah, this is a number in hex. How do we think? Yes, if you do command, comma, number, this results you want to see. And then we can do comma 10, and we'll only see the first 10 processes. Comma 100 will show us 100 processes. And if you want to use an exact number of exactly how many you have, you can do processes.count and use that as a number, or comma. I think that should work. Nope, that doesn't work. You'll need to just type the number.
Or save it as a variable, I guess. Probably you need to save it into a variable and then reference it. And...
Yeah, that's probably true. Sometimes these things work, sometimes they don't.
Yeah, well, actually, I'm quite impressed you did the full-on live. That's, like all those comments, every time I need to Google them, like even when I wrote like script, I totally forgot what I wrote about. Like I used it like once, like for like the process history thing. I was like, oh, that's kind of nice actually. And then there's something I was not able to do. I forgot what. I was like, okay, I'm just gonna try to write it in C, and the C like I mean the COM interface is still a bit behind. I don't think they've made any improvement yet, but I'm not sure. I didn't check it.
No, that was actually the reason I built it.
But I was saying, like you said, like the JavaScript one is pretty good.
Yeah, that was actually the reason I wrote the blog post, because I kept forgetting syntax, like specific syntax. So I just wanted to have it all down in one place.
Yeah, that's definitely a good idea to. And thanks for, I guess on behalf of the community, for writing those two blog posts. Are pretty good. You guys should definitely check it out. There is more example in it. How many words you say? Like you were quite proud of it. Was it like 8,000 words?
Yeah.
Yeah. So that's what happened when you hang out too much with Alex. You start counting in the number of words.
Oh yeah.
Cool. Well, thanks again.
Glad I'm calling it WinDbg. That's the other side effect.
Oh yeah, definitely. Yeah. Cool. Well, thanks again for your presentation, and yeah, hope to see you soon.
Thanks for inviting me.
No problem.